We'll continue with our discussion. So we are going to see the next type of receivers called as direct conversion receivers. So direct conversion, as the name indicates, is called as zero IF or homodyne architecture. So we have seen about the zero IF. We have seen only the second zero IF, but here the total whatever IF I have, I'm going to have it as zero IF only. So the first intermediate frequency itself is going to be equal to 0. So when omega IF equal to 0, I have the condition omega in will be equal to omega LO. So when you use omega in equal to omega LO, the difference will be equal to 0. So I'm going to use it as, so the 0 IF, whatever mixer circuit we have used for 0 IF, I'm going to replace that here. I'm going to have in phase and quadrature phase. So when you have in phase and quadrature phase, you will have two versions of same LO signal which are differed by 90-degree phase shift. Okay, so one for one, if one path, if you are going to use sine, for another part, I'm going to use cos. So the down conversion of asymmetrically moderated zero IF will lead to self-corruption. So we have seen that the one drawback of zero IF is the image and signal will be at the same frequency, which will lead to self-corruption. So unless you don't separate the band pass signals by their phase, in phase and quadrature phase, the image will be always corrupting your signal, and there cannot be efficient reproduction of your baseband signal. So that issue is always there in your zero IF, or called as direct conversion, or it is called as homodyne. It is called as homodyne receivers. Okay. So the diagram is shown, and you know that the condition for zero IF is the RF frequency and your LO frequency should be same. Only then you will have zero IF. So first, the absence of image greatly. First thing here, the image is not there outside your band, so that eliminates the need of filter, and image is inside the band that you can eliminate by using I and Q. So completely eliminating the image itself. So that is going to make my system very efficient. Channel selection is performed by low pass filter. You can use low pass filters which are available, on chip filters are available. So after, you can see after the mixer, I'm going to use LPF to select only my in phase and quadrature phase baseband channels. So this will eliminate the out of band interferers, and LPF will eliminate the other unwanted interferers, and use of I and Q mixers will eliminate the unwanted image which is present in the frequency itself. And also the spurs are reduced. So you know spur, we told you spur is the frequency which are integer multiples of your LO frequency. Since I'm using I and Q versions of my signal, the relatively I can reduce the number of spurs by 2, because I'm splitting the LO into separately for I path and Q path, right? So I'm reducing the number of spurs, and definitely my architecture is going to be very, very easy, and it is going to integrate well with my other components of my receiver. So except for front-ended band select filter, I need not have any external components. So only this is going to be off the chip. All other LPF, all other LOs, all LNA will be on chip components. So only this one you have to attach external to your circuit. So LNA has to be optimized for noise, gain, and most important 50 ohm impedance. It has to be matched. So this simplicity of architecture is helping many to design their circuits in the RF domain. So this architecture is very simple, and in a way it is going to reduce the image, it is going to suppress my spur, and it is going to offer a lot of attractive features. So now this direct conversion receivers are getting popular nowadays. So initially in 90s and 2000, the integration between the high frequency and low frequency was uh, not possible. But after the technology, it was a very good choice to integrate your omega in and omega LO, so that the IF is always made to be 0. Now we are going to see, even though this is going to be a very good choice for receiver, we are going to see what all issues arise in direct conversion receiver and how to resolve them. So most of the issues what we studied in heterodyne, we have the same thing here also. We are going to see how we can eliminate those issues here in zero IF